Stellar evolution. This is the order of star evolution.
The first stage of a star is protostar. A protostar is a very young star that is still gathering mass from its parent molecular cloud. The protostellar phase is the earliest one in the process of stellar evolution. For a one-solar mass star, it lasts about 1 million years. The phase begins when a molecular cloud first collapses under the force of self-gravity. It ends when the protostar blows back the infalling gas and is revealed as an optically visible pre-main sequence star, which later contracts to become a main sequence star. Next stage is the steady stage.
There are two types of steady stage: low and medium mass stars. Low mass stars are the smallest, coolest and dimmest main sequence stars, and orange, red or brown in color. Low mass stars use up the hydrogen fuel very slowly and consequently have long lives. Stars with a mass of between 8 and 20 solar masses have a more complex evolution. Initially, they evolve in the same way as low mass stars, turning into red giants and undergoing a core helium burning phase. One of these stars is our Sun. Then low and medium mass stars turn into red giants. A red giant is a luminous giant star of low or intermediate mass in a late phase of stellar evolution. The outer atmosphere is inflated and tenuous, making the radius large and the surface temperature around 5000 Kelvin or lower. The red giant then blows up and forms Planetary Nebula. A planetary nebula is a kind of emission. Nebula consists of an expanding glowing shell of ionized gas ejected from red giant stars late in their lives. The last stage of them is white dwarf. A white dwarf, also called a degenerate dwarf, is a stellar core remnant composed mostly of electron-degenerate matter. A white dwarf is very dense. Its mass is comparable to that of the Sun, while its volume is comparable to that of Earth. Another type of steady stage is high-mass stars. High-mass stars go through a similar process to low-mass stars in the beginning, except that it all happens much faster. They have a hydrogen fusion core, but much of the hydrogen fusion happens via the CNO cycle. Then they turn into super red giants. Red supergiants are stars with a supergiant size. They are the largest stars in the universe in terms of volume, although they are not the most massive or luminous. Then the super red giant blows up and forms supernova. A supernova is a transient astronomical event that occurs during the last stellar evolutionary stages of a massive star's life, whose dramatic and catastrophic destruction is marked by one final titanic explosion. This causes the sudden appearance of a new, bright star, before slowly fading from sight over several weeks or months. After supernova, it can turn into a black hole or a neutron star. A black hole is a region of spacetime exhibiting such strong gravitational effects that nothing, not even particles and electromagnetic radiation such as light, can escape from inside it. A neutron star is the collapsed core of a large star which before collapse had a total of between 10 and 29 solar masses. Neutron stars are the smallest and densest stars known to exist.